Okay, welcome Math 140 Trigonometry. This is the first video lecture in a series of video lectures I will be creating and posting to my YouTube channel for this class for the remainder of the semester. I sent you guys an email about this, but the basic idea is for each topic I will be posting a video lecture, about 20-30 minute long video lecture, maybe a little longer today. I will post that to my YouTube channel at least a day prior to class, and that gives you the chance to look at this video, and I recommend watching it before class starts. When we have our official class time, that will consist of a Google Hangout in which you guys will get together and we'll have a class discussion. You'll have a chance to ask me questions about the topic and material. Okay, so this is our first video lecture. And the topic today is inverse functions. Inverse functions. By the way, I'm recording this from my apartment in St. Louis, and I've got a small whiteboard here. It's not a perfect whiteboard, but nonetheless, it should work. It should work for our purposes. We're going to talk about inverse functions. Okay, why would we care about inverse functions in a trigonometry class? Well, the truth is the truth is for each trigonometric function, and there are 6 basic functions. If you guys remember, sine, cosine, tangent, cotangent, secant, and cosecant. For each trigonometric function, there's actually a corresponding inverse trigonometric function. And it's important to understand what these inverse trigonometric functions are like. So that's the idea of this chapter. We're leaving chapter 3. Chapter 3 we covered before spring break, and that had to do with trigonometric identities. We're getting into chapter 4, which has to do with inverse trigonometric functions. Okay, and it turns out you guys have actually already seen an inverse trigonometric function. And the way you've seen it is, if I were to ask you, find an angle such that the sine of that angle equals 1/2. So I could write that like this: 1/2 equals sine of theta. Find an angle such that the sine of that angle equals 1/2. Okay. How do we find this angle? Well, you guys already know how to do this. It turns out what we do is we take the inverse sine of both sides of this equation. That leads us to this equation. Inverse sine of 1/2 equals theta. Okay, the way we solve this equation is we take the inverse sine of this equation. And the inverse sine of 1/2 is 30 degrees, or it's equal to pi over 6. Okay. So you've already seen inverse trig functions, but what we're going to do in this chapter is develop a more systematic and thorough treatment of inverse trig functions. Now, before we talk about inverse trig functions, we need to talk about inverse functions themselves. What is meant by an inverse function? Okay, and before we talk about that, we actually need to talk about what a function is. So let's first talk about functions. I believe we have alluded to this in this class, but we may not have. I don't think we talked in detail about it. What is a function? Well, let me give you guys an example of a function. Okay, this is a function. As I'm sure you know, this is a parabola. The equation of a parabola is y equals x squared. Or we could write this as f of x equals x squared. What exactly is a function? A function is basically an operation. A function is something that takes an input and does something to it and produces an output. So in this case, what our function is doing is it's taking x as an input and then it's squaring x as the output. So for example, if we plugged in 2 as an input to this function, right? We took 2 and we square it, we get 4. Okay, so if we take 2 as an input, we square 2 and we get 4. Okay, that's what this function does. It squares things. Other functions perform different operations. Okay, so this is what a function is. Okay, now there are certain rules that apply to functions, and the basic rule for a function is whenever you have an input, you have to have only one output. Okay, so for instance, you can't have one input producing 2 or more outputs. Whenever you have an input, it has to produce a well-defined output. Let me give you an example of something that's not a function. So not a function. If we took this function and we flipped it over, okay? We flipped over this parabola and got something like this. Okay. this is not a function, because if we choose a certain input, such as this input right here, okay, this input actually produces two outputs, and that's not allowed for a function. Now over here, if we choose a certain input, okay, if we choose a certain input, we can see that we get exactly one output for that. Now, what's interesting here is it turns out there's two inputs that produce the same output. That's okay, that's legal. Two inputs can produce the same output, but we can't have one input producing two outputs. That's not allowed, so this is not a function. And there's something called the vertical line test, which I'm sure you've heard about. Vertical line test. Okay, the vertical line test is basically a test to see whether you have a function or not. And what it says is if you draw any vertical line, that vertical line can intersect your function at most one point. So if I choose some vertical line like this, that vertical line is intersecting my function at most one point. Okay, so this is a function. However, if I choose a vertical line in this case, that vertical line is intersecting this relationship. I won't call it a function because it's not. It's a relationship. It will intersect this graph at more than one point, and so these 2 points, and therefore this is not a function. So that's a whirlwind introduction to functions and non-functions. Okay, this is more of an algebra day than a trigonometry day. Now I'm going to erase here this board, and again, it's a small whiteboard. I don't know if I told you guys this already in this lecture, but I'm recording this from my apartment in St. Louis, and I went out and bought a small whiteboard. And this isn't exactly ideal, but it'll work for our purposes. So what we now want to talk about are inverse functions. Should I erase the topic? I should have just kept that. Inverse functions. What is an inverse function? And what I want to do is I want to talk about what a one-to-one function is. What is a one-to-one function? A one-to-one function is a function that has exactly one for each output. There is exactly one input. Okay, so I mentioned to you guys before, it's okay for a function to have two or more inputs that produce the same output. You can't have one input producing two outputs, but it's okay to have two or more inputs produce the same output. If you have a one-to-one function though, a one-to-one function, that's not allowed. So a one-to-one function, for each output, there's only one input. Let's consider some examples of either one-to-one functions or things that aren't one-to-one functions. Let's consider this example of this line, which is the line y equals x. Okay, y equals x. Is this a one-to-one function? It turns out this actually is a one-to-one function because for each input, there's exactly one output. For each output, there's exactly one input. Okay, so this is one-to-one. 1, 2, 1. Okay, how about, here's another example of a function that we just considered, a parabola. Is a parabola, and actually I'm going to use this function notation. Let's think of a function as something where we have an input, it does something to an input, produces an output. Okay, is this a one-to-one function? This is not a one-to-one function because if you choose some input, or some output, let's choose this output. Okay, this output has two inputs, right? This output right here, which could be some value. We could choose some value. It could be y equals, let's see, how about y equals 4? Okay, y equals 4. Y equals 4, there's two ways you can get y equals 4. You could plug in 2 and square it, right? So f of 2 equals 2 squared equals 4, or you could have f of minus 2 equals minus 2 squared equals 4. So there's actually two values that give you 4, plus and minus 2. This is not a one-to-one function, not one-to-one. Okay, it's not a one-to-one function. Okay, and there's something called the horizontal line test. Just like we had a vertical line test to see if you have a function, there's something called a horizontal line test. Okay, that tells you whether you have a one-to-one function, horizontal line test. Okay, and this tells you whether you have a one-to-one function. And it's very simple. It basically says draw any horizontal line. Any horizontal line can intersect your function at only one place. If it intersects the function at only one place, you have a one-to-one function. If it intersects this function at more than one place, you do not have a one-to-one function. If I choose any horizontal line here, like this one, only intersects this function at one place, so this is one-to-one. If I choose this horizontal line, or if I can find any horizontal line that intersects this function at more than one place, it's not a one-to-one function. So this is not a one-to-one function. Okay, so that's what a one-to-one function is. Okay. Now you might wonder, well, why do I care whether something's a one-to-one function? Well, it turns out if you have a one-to-one function, this means there's an inverse function exists. An inverse function exists. So the importance of one-to-one functions are, if you find a one-to-one function, you can find an inverse function, okay? If you don't have a one-to-one function, you can't find an inverse function, okay? So that's an important point. That's why we care whether a function is one-to-one. If a function is one-to-one, we can find an inverse function. If it's not one-to-one, we can't find an inverse function. Okay, let me talk a little bit about notation. If you have a function f of x, okay, the inverse function is denoted f to the minus 1 of x. That's how we denote the inverse function that corresponds to this function, f of x. Okay, important point. The inverse function, this does not mean 1 over f of x. That's not what that means. So we don't mean, when we say f to the minus 1 of x, we don't mean 1 over f of x. What we mean is really the inverse function of f of x. Okay, let me talk a little bit about just intuitively, what does an inverse function do? Inverse functions. What does an inverse function do? An inverse function, so f to the minus 1 of x, undoes the operation of f of x. It undoes that operation. Okay, if you think of a simple, silly analogy, if I were to dig a hole, okay, my operation was to dig a hole. What would be the inverse function to digging a hole? Well, the inverse function of digging a hole would be to fill the hole back up again. So an inverse operation undoes or negates the operation of a function, f of x. An inverse function negates the operation of a function. And that's important. So I'm going to take a little side note here, talk about composition. We haven't really talked about composition, but good news, folks. You guys are smart. This is a simple topic. Okay. If I had two functions, f of x, let's say f of x equals x plus 1, and I have another function g of x equals x squared, what I could do is I could plug in, excuse me, let me flip these around. X squared, don't mean to confuse you guys here, and this is x plus 1. So the operation of f of x is to take something, an input, and square it. The operation of g of x is to take an input and add 1. What you can do is you can actually compose these two functions together. What if instead of taking f as an input, you took g of x, instead of taking x as an input into f, you plugged in g of x as an input. So this is called composition. If we did f of g of x, okay, so instead of taking x as an input to f, we take g of x as an input to f. We plug in the output of this function. This is called composition, and we can actually write this in a funny way. We can say f composed with g of x. Okay, f composed, we use this little open circle. F composed with g, which means we plug in g of x as an input into f of x. What happens here is wherever we see x, we're going to plug in x plus 1. So what I have here is x plus 1. I plug in x plus 1 as my input to f, and then I square this, and I get something. If we square this out, we get x squared plus 2x plus 1. Okay, so this is called composition. Don't get too hung up about this. Don't freak out about it. I just need to kind of introduce this to you guys. The point why I'm doing this is, if we do the inverse function composed with the function itself, in other words, we take a function and then we apply the inverse to it, okay? This can be written as f inverse composed with f of x, okay? In other words, what if we do something f of x and then we then do the inverse of that right after that? What if I dig a hole and then I fill it back in? What do I get? I get back to where I started, okay? So if we compose f of x with the inverse, these two functions compose together, what this does is negate stuff and we simply get x, okay? We simply get x. Let me go back to an example you guys know how to do. When I said to you, find the angle such that the sine of that angle equals 1/2, okay? Let's say I said to you guys, find an angle such that the sine of that angle equals 1/2. How did we solve this? Well, actually what we did is we took the inverse sine. We took the inverse sine of both sides of this equation. As long as you do the same thing to both sides of the equation, you're okay. So we took the inverse sine of both sides of the equation. We took the inverse sine of 1/2 and the inverse sine of x. Here we're actually composing inverse sine with sine. We're taking the inverse sine of a sine, okay? This negates, these two negate each other, and you actually get out x, okay? So whenever you compose or take the inverse of the function itself, you just get out the input x, okay? So this is how we solve this problem, and we know x equals 30 degrees or pi over 6. Okay, if you guys have questions, don't get too hung up on composition. If you have questions about it, we can talk about it tomorrow in our Google Hangout, okay? All right, let me talk to you guys. We've done that. Let me talk to you guys about finding inverse functions for things. Okay, how do you find an inverse function? How do you find an inverse function? Okay. Let's take a very simple example and let's suppose I had a function f of x. Okay, let's say actually, let me give you guys some steps. I'll give you some steps. Here are the steps. Write y instead of f of x. That's step 1. Step 2 is exchange x and y. Okay, step 3 is solve for y. Step 4 is replace y with f inverse of x. Okay? Let's do an example of this. Okay, we're going to do an example. This is how we find an inverse function for a given function. Let's say I gave you guys the function f of x equals square root of x. Okay, this is my function. What does it do? It takes an input and takes a square root. How do I find the inverse of this function? Okay, well, step 1 says, what I do is I write y instead of f of x. So I write this as y equals square root of x. That's step 1. Step 2 says that I exchange x and y. So I exchange x and y. So I write this now. I flip these around. x equals square root of y. Okay, step 3 says I solve for y. Now, if this was my equation I wanted to solve for y, how would I solve for y? What I would do is I would square both sides. So I'm going to square both sides. If I did that, I get x squared equals square root of y squared. Okay? What happens when I square the square root of something? I just get back the thing itself. So this leads to this equation. X squared equals y. Okay? Or y equals x squared. Doesn't matter the order I write that. Step 4 says I replace y with f of minus 1 of x. So I write f minus 1 of x equals x squared. Okay. So this is the inverse function to square root of x. Okay, this is the inverse function to square root of x. All right. So if f of x is taking the square root of something as an input, the inverse function to that squares something. Okay. Let's do another example so you guys get comfortable with this. Okay, another example. This is example 2. Let's say let's say we have the function f of x equals x cubed plus 1. Okay, and I want to find the inverse function to this. Let's go through my steps. Step 1 says that instead of writing f of x, I write y. So y equals x cubed plus 1. That's step 1. Step 2 says I exchange, and by the way, what does this function do? If you had to describe it in words, it takes an input, it cubes that input, and it adds 1 to it. So now what I do is I switch x and y here, I exchange x and y. So now I get x equals y cubed plus 1. Okay? And then at step 3 says that I should solve for y. So solve for y. Well, let's solve for y. How would I solve for y? The first thing I'm going to do is subtract 1 from both sides. So now I get y cubed equals x minus 1. Okay? And then if I want to solve for y here, I want to isolate y. What would you do here? You take the cube root of both sides. Cube root of both sides. Okay, if I do that, I take the cube root of both sides. Okay, what's the cube root? Excuse me, I didn't write y cubed. What's the cube root of something cubed? Just the thing itself. So this leads me to y equals the cube root of x minus 1. Then the final step for finding my inverse function is f of x. I just write f minus 1 of x equals the cube root of x minus 1. That's the final step. And I've now found my inverse function. This is the inverse function that corresponds to this function right here. Again, why are we doing all of this? Because we want to understand inverse trig functions. But to do that, we first need to understand what inverse functions are. Okay. Now, how do I know I've found the right inverse? Okay, let me erase this board because I want to go back to our original example. How do I know I found the correct inverse? How do I know I found the right inverse? How do I know I find the right inverse? Let's go back to one of our examples. So our example was we had f of x equals square root of x. We found the inverse for this, f minus 1 of x equals x squared. This was our inverse for this function. How do I know I found the right inverse? A simple way. You compose the two. So if I compose f minus 1 composed with f of x, if I found the right inverse, this should equal. Let's see what happens here if I do this. If I compose, in other words, what I'm going to do is do f minus 1 of f of x and see what happens. Instead of plugging in x to my inverse function, I'm going to plug in f of x into my inverse function. So what I have here is I'm going to plug in square root of x into my inverse function, which squares stuff. So I'm taking square root of x and I'm squaring it, right? I'm taking the square root of x as an input into the squaring function x squared. If you square something that's a square root, you just get x, right? You get the thing itself, and now I can put a big check mark. Because now I know it, I have proven this is my inverse function, correct inverse function. Because whenever you compose an inverse function with the function itself, in other words, whenever you perform the operation of a function and then perform an inverse operation on that, all you do is you get back x. You just get back your input. These two things negate each other. I got back my input, so I know I have the correct inverse function here. Okay. I know there's a lot we've covered. We're going to cover one more small aspect of this, and then I'm going to stop the video, and then we have time to talk about it tomorrow. We're going to talk about graphing inverse functions. We're going to talk about graphing inverse functions, okay? And let's use this example. Let's go back to this example where f of x equals square root of x. Let's create a graph of that. Okay. Here's our graph. What does the square root of x look like? The square root of x, what it happens is it goes like this, and it kind of levels off like this. Goes like that. This is what I'm going to do with my colored pens. Okay, this is f of x equals square root of x. Okay, so this is f of x equals square root of x. How do I know what the graph of an inverse function looks like? And here's the trick. If you want to graph an inverse function, draw a line. Draw the line, the particular line of y equals x. Draw a diagonal line. Okay? And basically, the graph of an inverse function always is, the graph of an inverse function to f of x will always be the reflection of f of x about the y equals x line, axis. So imagine I took this thing and I reflected it, I kind of rotated it around this line or reflected it, then that will give me my inverse function. Let me choose a better color, I'll choose blue. So my inverse function will look like this. Didn't quite come out right there, but looks like that. Okay, it kind of looks like a fish. The two together. This is f minus 1 of x equals x squared. That's what the graph of x squared looks like. Okay, and this is f of x equals square root of x. So to get the graph of an inverse function, to graph the inverse function, graph inverse function, f minus 1 of x, reflect f of x about the y equals x axis. Reflect f of x about the y equals x axis, and you get f minus 1 of x. That's how you get an inverse function. Okay? And you might think to yourself, well, isn't this is a parabola, isn't it missing the left side here? It is, and the reason is, normally we would graph the other side, but we have to think carefully. If we have f of x equals square root of x, and this is a technical point, don't worry too much about it, but basically the domain of this is just starting here. You can't have negative square roots, so it starts here and goes to here, so we really only graph this part of it. But don't worry too much about that. Basically though, to get an inverse function, right, if you have the graph of a function and you want to get the graph of the inverse function, draw the line y equals x, reflect the inverse function about the line reflect the function f of x about the line y equals x, and you will get your inverse function, which we found. We know this is the inverse function because we found it earlier. Okay, that concludes this video lecture. It had to do with inverse functions. What is a function? The function is something that passes the vertical line test. What is a one-to-one function? A one-to-one function is a function that passes the horizontal line test. It's a function that for each output has exactly one input. Okay. Why is a one-to-one function important? Because if you have a one-to-one function, you can find an inverse function to that function. If you don't have a one-to-one function, you can't. Okay. And then we talked about how do you actually find the inverse function of a function, and we went through 4 steps. And then we talked about how do you know you have the right inverse function. Well, the way you know you have the right inverse function is if you compose the inverse function with the function itself. In other words, if you perform the operation of the function, and then right after that, you perform the inverse operation. The two should negate each other, and you just get out x. And then we finally talked about if you're given a function and you want to see if you're given a graph of a function and you want to see what the graph of the inverse function looks like, what we can do is we know how to do that now. We basically create a line y equals x and reflect the graph of the function about that line. So we've gone on long enough. That's our video lecture. Take a look at this lecture, watch it, and then we'll have a discussion time together tomorrow, March 31st at 1:30, a regular class time. All right, I'll see you guys then. Goodbye.